Prompt engineering for book authors. This content is designed for the world of computers and modern technology. It is created especially for independent authors, technical writers, and publishing professionals, people who want to work smarter, streamline their workflows, and get more done in less time. The approach is technical, yet practical, presented step by step in a clear, tutorial-style format. You will find it highly visual, easy to follow, and focused on real actions you can apply immediately. The structure and content are powered by advanced AI models, ensuring clarity, consistency, and professional quality guidance throughout.
Introduction: The Paradigm Shift in Digital Authorship. Sections: Section 0.1, Redefining the Writer's Toolkit for the Algorithmic Age. Section 0.2, The Economics of Efficiency, Why Prompt Engineering Matters. Section 0.3, Establishing the Human-in-the-Loop Methodology. Section 0.4, Navigating the Technical Landscape of Large Language Models. Writing has always been an interaction between human intent and technological constraint. Whether carving into clay tablets, hammering keys on a manual typewriter, or organizing scenes in Scrivener, the tool dictates the workflow. We are now witnessing the most significant transformation in this relationship since the invention of the printing press, the arrival of the algorithmic age. This book is not about surrendering your creative voice to a machine. It is about understanding that your role is evolving from a sole laborer to an executive editor and architect of narrative. The generative AI revolution does not replace the author, it amplifies the author's intent, provided that intent is communicated with precision. As technical writers, independent novelists, and publishing professionals, we must view large language models, LLMs, not as magic boxes, but as deterministic engines of efficiency. The goal of this chapter is to recalibrate your perspective. We are moving away from the romanticized notion of the tortured artist and toward the reality of the high-output creative director. 0.1 Redefining the Writer's Toolkit for the Algorithmic Age. For the last 30 years, the writer's toolkit has remained statically defined by word processors and reference engines. You wrote, you researched via search engine, and you edited manually. The cognitive load of every single step rested entirely on your neural pathways. In the algorithmic age, the toolkit shifts from passive tools, which wait for input, to active assistants, which predict and generate. This requires a fundamental change in how we visualize our workspace. We are no longer staring at a blank page, we are managing a dynamic context window. Consider the synthesizer in music production. Before its invention, if you wanted a violin sound, you had to hire a violinist. After the synthesizer, a single composer could orchestrate an entire symphony. The composer still needed to know music theory, composition, and arrangement. Similarly, prompt engineering allows a single author to orchestrate research, drafting, and developmental editing at scale. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison. On the left, labeled the analog stack, a messy desk with a typewriter, scattered papers, physical dictionary, and a stressed human silhouette. On the right, labeled the algorithmic stack, a clean futuristic interface displaying a central hub connecting to nodes labeled context window, vector database, and LLM API, with a calm human silhouette directing the flow like a conductor. Digital, isometric vector art style, blue and white color scheme, clean lines. The new toolkit relies on your ability to interface with these models using natural language as code. Your prompt is not just a question, it is a set of executable instructions. Asterisk traditional writing input asterisk. I need to write a chapter about database locking. Asterisk algorithmic toolkit input, prompt engineering, asterisk. Role: technical writer. Context: Chapter 4 of SQL Mastery. Tone: authoritative, didactic. Task: explain optimistic versus pessimistic locking. Constraint: use a library analogy, include a SQL code block example. By structuring the request, you transform the LLM from a chat partner into a specific utility. The shift here is psychological. You are no longer writing the text directly, you are writing the specification for the text. 0.2 The economics of efficiency, why prompt engineering matters. The independent publishing market is a volume game governed by the laws of supply and demand. In the past, the bottleneck was always human production speed. A prolific author might produce 4 books a year. With prompt engineering, that same author can maintain quality while tripling output, or conversely, produce the same amount of work in a fraction of the time, freeing up resources for marketing and business development. We must look at writing through the lens of ROI, return on investment. Every hour you spend staring at a blinking cursor trying to figure out a transition sentence is an hour of negative equity. It is time burned without a tangible asset produced. Prompt engineering minimizes this latency. It solves the blank page problem instantly, allowing you to move straight to the refinement phase. This is not about cutting corners, it is about allocating your cognitive energy to where it matters most: high-level strategy, creative nuances, and emotional resonance. Workflow stage: traditional time cost, AI-augmented time cost efficiency gain. Notice that the final polish stage retains the same time cost. This is intentional. Efficiency allows you to race through the structural and generative phases, but the final human verification cannot be rushed. The economic value lies in collapsing the time between idea and first draft. 0.3 Establishing the human-in-the-loop methodology. Efficiency is dangerous without control. A common fear among authors is that AI will produce generic, hallucinated, or soulless content. This is a valid concern if one relies on blind generation, asking the AI to write a book and pasting the result into a document. This is professional malpractice. The methodology we will apply in this book is human-in-the-loop, HITL. In this workflow, the AI is the engine, but the human is the steering wheel, the map, and the brake. You are the senior architect, the AI is the junior draftsman. The HITL workflow follows a cyclic pattern: define, generate, evaluate, iterate. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a circular workflow process. 4 distinct segments in a circle. Top: define, human, icon of a blueprint. Right: generate, AI, icon of a neural network node. Bottom: evaluate, human, icon of a magnifying glass or eye. Left: iterate, hybrid, icon of 2 gears interlocking. Arrows connect them clockwise. Center of the circle contains text: quality control core. Professional infographic style: flat design, teal and dark gray palette. Define: you provide the context, constraints, and examples. Generate: the model produces output based on those constraints. Evaluate: you rigorously fact-check, tone-check, and review the output. Iterate: you refine the prompt or edit the text manually to bring it up to standard. If the output is factually incorrect or tonally flat, the fault lies with the prompt, not the model. Adopting this mindset empowers you. It moves you from a passive recipient of bad text to an active debugger of your own instructions. 0.4 Navigating the technical landscape of large language models. To master prompt engineering, you do not need to be a data scientist, but you do need to understand the fundamental limitations and parameters of the technology. Treating an LLM like a human leads to frustration, treating it like software leads to mastery. We must understand 3 core technical concepts: tokens, context window, and temperature. Tokens are the currency of LLMs. The model does not see words, it sees chunks of characters. Roughly 1,000 tokens equal 750 words. Understanding this helps you manage the memory of the conversation. If you overload the model with too much text, it forgets the beginning of your instruction. Context window is the workspace size. Just as a human working memory can only hold a few thoughts at once, an LLM has a hard limit on how much information it can process in a single turn. Efficient authors learn to modularize their work, breaking books down into chapters or scenes that fit within this window. Temperature controls creativity. A temperature of 0 makes the model deterministic and factual, ideal for technical writing. A temperature of 1.0 makes it erratic and creative, ideal for brainstorming fiction. Asterisk example API configuration for technical non-fiction asterisk. Model: GPT-4 latest. Temperature, 0.2 / low creativity, high precision. Max_tokens, 2048. Top_P, 1. Frequency_penalty, 0.0. Presence_penalty, 0.0. In the chapters that follow, we will strip away the hype and focus on the syntax of instruction. We will build a library of prompts that you can deploy immediately. We will treat the English language not as art, but as a programming language for intelligence. The paradigm has shifted. The authors who thrive in the coming decade will be those who can bridge the gap between human creativity and machine efficiency. Let us begin.
Chapter 1: The Mechanics of Language Models. Sections: Section 1.1, Decoding Tokens, Parameters, and Probabilistic Generation. Section 1.2, Understanding Context Windows and Memory Limitations. Section 1.3, Temperature, Top P, and Frequency Penalties Explained. Section 1.4, Selecting the Right Model for Narrative versus Technical Tasks. To master any craft, one must understand their tools. A master carpenter understands grain direction and wood hardness, a photographer understands ISO and aperture. As an author stepping into the algorithmic age, you must move beyond viewing AI as a magic black box and understand it as a probabilistic engine. When you type a prompt, you are not conversing with a conscious entity. You are manipulating a complex mathematical field. Understanding the physics of this field, tokens, context windows, and parameters allows you to exert control over the output. This chapter strips away the hype to reveal the mechanical levers you can pull to optimize your writing workflow. 1.1 Decoding Tokens, Parameters, and Probabilistic Generation. The fundamental unit of a large language model, LLM, is not the word, it is the token. Humans perceive language semantically, meaning, but models perceive language numerically, sequences. This disconnect is the source of many prompting frustrations. The tokenization process. When you input text into a model like GPT-4 or Claude, your words are immediately chopped into chunks of characters called tokens. A common rule of thumb is that 1,000 tokens equal roughly 750 words. Simple words like book are single tokens. Complex words like multidimensional may be split into multi, dimension, and vul. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a sentence being dismantled into tokens. Visual style, sleek, technical infographic, blueprint aesthetic with cyan and white lines on a dark blue background. Subject, the sentence, the quick brown fox entering a digital funnel and emerging as numbered blocks, the 234, quick, 89, brown, 12. Lighting, glowing neon edges on the blocks. Layout, left to right flow. Why does this matter to an author? Because the model charges you by the token, and its memory is limited by tokens. Furthermore, models struggle with tasks involving character-level manipulation, like write a poem where every word ends in the letter T, because they literally cannot see the individual letters, only the token block IDs. Probabilistic generation. Once tokenized, the model does not think. It predicts. Based on the billions of parameters, weights, tuned during its training, it calculates the statistical probability of the next token in the sequence. Consider the phrase, the detective picked up the smoking ______. A human predicts gun. An LLM assigns a probability percentage to gun, a lower percentage to cigarette, and a near 0% to banana. It selects the next piece based on these weights. Your job as a prompt engineer is to stack the probabilities so high that the model has no choice but to generate the specific narrative nuance you require. 1.2 Understanding Context Windows and Memory Limitations. The context window is the author's workbench. It represents the maximum amount of text the model can consider at one time. This includes your instructions, the reference material you paste in, the chat history, and the model's generated response. The sliding window effect. In the early days of AI, circa 2022, context windows were small, roughly 4,000 tokens, 3,000 words. If you pasted a chapter and asked for a critique, the model would forget the beginning of the text by the time it finished reading the end. Today, models boast windows of 128K to 1 million tokens. However, fitting text in the window does not guarantee the model will attend to it effectively. This is known as the lost-in-the-middle phenomenon. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the concept of a context window. Visual style, isometric 3D visualization, clean and modern. Subject, a long conveyor belt representing the context. Items in the middle of the belt appear slightly translucent or blurry, while items at the start, input, and immediately before the processing arm, recent output, are sharp and solid high-fidelity objects. Labeling, prime context at the ends, attention drift in the center. Optimization strategy. For long-form projects, do not rely on the model to remember a character's eye color mentioned 50,000 words ago. Efficient authors manage the context window actively. Summarize frequently, compress previous chapters into dense summaries before starting a new session. External documentation, keep a series Bible file and upload only the relevant character sheets for the current scene. Clean the slate, start fresh chat sessions for new chapters to prevent context pollution from previous, unrelated brainstorming. 1.3 Temperature, top P, and frequency penalties explained. Most users interact with the default settings of chat interfaces. However, if you are using the API or advanced playgrounds, like OpenAI's Playground or specialized writing tools, you have access to the thermostat of the model. These settings control the hallucination versus determinism scale. Temperature. Temperature controls randomness. Low temperature, 0.0 to 0.3, the model becomes conservative. It picks the most likely next token almost exclusively. Use case, copy editing, factual summaries, formatting references, coding. High temperature, 0.7, 1.0 plus, the model takes risks, choosing lower probability tokens. This increases creativity but introduces instability. Use case, brainstorming plot twists, writing poetry, generating diverse dialogue. Top P, nuclear sampling. Top P creates a cutoff for the token selection pool. If you set top P to 0.9, the model only considers the top 90% of probable tokens and discards the bottom 10% of nonsense. Pro workflow, I recommend keeping top P fixed, usually around 1.0 or 0.9, and adjusting temperature to change the vibe. Adjusting both simultaneously can lead to erratic results. Frequency and presence penalties. These parameters prevent repetitive loops, the bane of AI writing. Frequency penalty penalizes tokens based on how many times they have appeared in the text so far. Stops, he ran and ran and ran. Presence penalty penalizes tokens based on whether they have appeared at all. Encourages introducing new topics. Parameter recommended setting, fiction, recommended setting, technical. 1 point for selecting the right model for narrative versus technical tasks. Not all large language models are created equal. Just as you wouldn't hire a technical writer to compose a sonnet, you should not use a logic-optimized model for prose generation. The reasoning models, e.g., GPT-4o, 01 preview. These are the heavy lifters. They excel at following complex, multi-step instructions. They are smart but can be rigid in their prose style, often defaulting to corporate or academic tones and less heavily prompted otherwise. Best for plot outlining, developmental editing, world-building logic, checking for plot holes, and formatting citations. The prose models, e.g., Claude 3.5 Sonnet, specific open-source fine-tunes. Certain models demonstrate a higher aptitude for nuance, subtext, and human-sounding dialogue. The Claude family, for instance, is widely regarded in the author community for having a warmer, more literary default voice and a larger, more reliable context window. Best for drafting scenes, rewriting dialogue, style emulation, and handling large manuscripts. The speedy cost models, e.g., GPT-4o Mini, Haiku. These are smaller, faster, and cheaper. They lack deep reasoning capabilities but are incredibly efficient for rote tasks. Best for bulk generating synonym lists, basic proofreading, tag generation for metadata, and summarizing short articles. Figure, extra detailed AI-ready prompt for AI-generated diagram comparing AI models. Visual style, radar chart, spider chart. Data points, creativity, logic, context memory, speed, cost. Series 1, logic model, spikes high in logic and reasoning. Series 2, prose model, spikes high in creativity and context. Series 3, speed model, spikes high in speed and low cost. Color palette, distinct, high contrast colors, magenta, cyan, yellow, against a dark grid. The hybrid workflow, the most efficient authors use a multimodal approach. Use a reasoning model to outline the chapter and ensure logical consistency. Then, feed that outline into a prose-optimized model to draft the actual text. Finally, switch back to a logic model for the final copy edit. Understanding these mechanics shifts your perspective. You are no longer asking a machine to be creative. You are engineering a probabilistic outcome using precise parameters and selecting the correct engine for the load.
Chapter 2. Establishing the System Architecture. Sections, Section 2.1. Crafting robust system prompts to define AI personas. Section 2.2. Context injection. Priming the engine with style guides. Section 2.3. Zero-shot, one-shot, and few-shot prompting techniques. Section 2.4. Setting up an iterative workspace for high-volume output. In the previous chapter, we stripped the AI down to its mechanical studs, examining tokens and probabilities. Now, we must build the house. If Chapter 1 was the physics of the engine, Chapter 2 is the blueprint of the factory. As an author seeking efficiency, you cannot rely on sporadic, ad hoc prompting. You need a repeatable system architecture. A robust system architecture turns a chaotic conversation with an AI into a structured editorial pipeline. It prevents the model from drifting into generic tropes and forces it to adhere to your specific creative vision. We are moving from asking the AI questions to programming the AI with natural language. This chapter outlines the 4 pillars of this architecture: defining the persona, injecting context, utilizing shot-based learning, and establishing an iterative workspace. By the end of this section, you will have a reusable framework that produces consistent, high-quality text that sounds like you, not a machine. 2.1 Crafting robust system prompts to define AI personas. The most common failure point for authors using AI is the blank slate problem. When you open a fresh chat context, the model is a generalist, a jack of all trades with no specific allegiance to your genre or voice. To fix this, we must craft a system prompt. Think of the system prompt as the job description, the employment contract, and the onboarding manual all rolled into one. It is the directive that sits above all other instructions, filtering every subsequent output. You aren't just asking for text, you are instantiating a specific persona to do the writing. A generic prompt asks, write a mystery scene. A robust architectural prompt defines the writer first. It establishes constraints, tone, and expertise levels before a single word of fiction or technical copy is generated. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a persona layer flowchart. The visual should depict a funnel. At the top, raw LLM intelligence pours in. It passes through a filter labeled system prompt persona definition. Inside this filter are layers, role, tone constraints, audience awareness, and negative constraints. The output at the bottom is specialized narrative engine. The style should be clean, isometric, vector art, technical blue and white color scheme. The anatomy of a system instruction. To build this persona, we use a structured format. While natural language works, separating instructions into logical blocks, often using XML style tags or markdown headers, helps the model parse your intent with higher fidelity. Below is a template for a technical thriller persona. Notice the specificity regarding what the AI should do and what it must avoid. System_role. You are a best-selling techno-thriller author and senior technical editor. Your writing style blends the pacing of Michael Crichton with the technical density of a software documentation lead. System_role. Core directives. 1. Authority. Use active voice. Avoid hedging words, maybe, perhaps, likely. 2. Precision. When describing technology, use correct terminology. Do not Star Trek the science, keep it grounded in near-future realism. 3. Pacing. Sentences should be punchy during action sequences, under 10 words. Longer, complex sentences are permitted only during exposition. Core directives. Negative constraints. Do not use flowery metaphors or purple prose. Do not summarize the moral of the story at the end of a scene. Avoid the words shiver, spine-chilling, tapestry, and testament. Negative constraints. When you paste this into your context window first, you lock the model into a specific cognitive mode. It stops trying to be a helpful assistant and starts acting like a disciplined writer. This initial investment creates consistency across thousands of words of output. 2.2 Context injection, priming the engine with style guides. A persona defines who is writing. Context injection defines how they adhere to your specific universe. In Chapter 1, we discussed the context window, the limit of the RE's short-term memory. Context injection is the strategic utilization of that space to load your style Bible. If you are writing a technical manual, this injection includes your glossary of terms. If you are writing fiction, it includes character sheets and world-building rules. Without this, the AI will hallucinate details or drift out of character. We treat this as priming the engine. Before requesting new content, you feed the model the static data it needs to reference. This reduces the need for heavy editing later because the AI has the rules visible in its immediate history. The Style Guide Injection Block. For maximum efficiency, maintain a master text file, or cheat sheet, that you can copy-paste at the start of every session. This ensures that Chapter 10 feels like it belongs in the same book as Chapter 1. Here is an example of a compact style guide injection designed for an independent author writing a fantasy series. ## narrative style guide, reference only. *** world rules ***. Magic system, ether costs physical stamina. No casting without exhaustion. Technology level, steam-powered machinery exists but is rare. Capital city, Oak Haven, industrial, smoggy, stratified. *** character voices ***. Kale, short sentences. Grunts. Uses slang rust as a curse. Ilara, academic vocabulary. Polysyllabic words. Never uses contractions. *** formatting rules ***. Thoughts are * italicized star. Telepathic communication is ** bold ***. No adverbs in dialogue tags, e.g., he said loudly - he shouted. By injecting this block, you convert the AI from a creative writing intern into a continuity editor. When you subsequently prompt, write a dialogue between Kale and Ilara about the broken steam engine, the model draws upon the character voice's definitions automatically. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the context injection mechanism. A side view cutaway of a computer terminal screen. On the left, a document labeled User Input. In the middle, a context buffer visual representation showing distinct blocks of data, style guide, character sheet, previous chapter summary. These blocks are being fed into a glowing central processor labeled LLM processing. The output arrow points to consistent text generation. Lighting should be cybernoir, neon accents, focusing on the modular nature of the data blocks. 2.30 shot, one-shot, and few-shot prompting techniques. Once the persona is set and the context is injected, you must decide how to ask for the work. In computer science, we classify prompts based on how many examples we provide to the model: 0-shot, 1-shot, and few-shot. Understanding which technique to use is crucial for workflow optimization. Using the wrong method is often why authors feel the AI doesn't get it. 0-shot, the blind request. Zero-shot prompting offers no examples. You simply give a command, write a scene where the detective finds the gun. Best for brainstorming, outlining, or high creativity tasks where you want the AI to surprise you. Risk: high variance. The output might be brilliant, or it might be completely off-tone. One-shot, the singular example. One-shot prompting provides a single example of the desired format or tone before asking for the new content. Example: here is an example of a product description I wrote, insert text. Now, write a new one for a toaster using the same style. Best for formatting tasks or establishing a baseline voice. Few-shot, the gold standard for consistency. Few-shot prompting involves providing 3 to 5 examples of input and desired output. This is the most powerful technique for technical writers and authors seeking uniformity. By seeing a pattern, the AI deduces the hidden rules of your style that you might struggle to articulate in words. Technique input structure best use case efficiency rating. 2.4 Setting up an iterative workspace for high-volume output. The final piece of the architecture is the physical and digital setup of your workspace. Efficient AI authorship is not linear, it is recursive. You do not simply click generate and publish. You build a loop. To manage high-volume output, you need a workspace that separates generation from assembly. I recommend a 3-monitor setup, or 3 distinct windows: the prompt interface, the assembly document, Word Scrivener, and the context reference, your notes. The refinement loop. Never aim for perfection in the first prompt. Instead, establish a chain of thought workflow. This involves breaking a complex writing task into granular steps within the same chat window. Ideation step: ask the AI to outline the scene beats. Review step: criticize the outline. Tell the AI what to change. Drafting step: ask the AI to write the prose based on the revised outline. Polishing step: ask the AI to tighten the prose or remove passive voice. This iterative approach saves time. It is faster to generate a rough draft and have the AI refine it 3 times than to spend hours crafting one perfect megaprompt that might fail. Figure: extra detailed AI-ready prompt for AI-generated diagram showing the iterative workflow loop. A circular diagram. Step 1. Prompt. Step 2. Generate. Step 3. Evaluate. Step 4. Refine instruction. The center of the circle contains a diamond labeled final output. Arrows flow clockwise. The visual style should be sleek, corporate infographic style, using shades of teal and gray to imply professionalism and flow. By establishing this architecture, persona, context, few-shot examples, and iteration, you stop fighting the tool. You move from gambling on random outputs to operating a predictable content engine. This is the foundation upon which we will build specific drafting strategies in the coming chapters.
Chapter 3: Structural Blueprinting and Ideation. Sections: Section 2.1 Crafting Robust System Prompts to Define AI Personas. Section 2.2 Context Injection, Priming the Engine with Style Guides. Section 2.3 Zero-shot, One-shot, and Few-shot Prompting Techniques. Section 2.4 Setting up an iterative workspace for high-volume output. In Chapter 2, we established your system architecture, the factory floor where your writing is produced. You defined your persona, established your operational constraints, and set the parameters for the AI's behavior. Now, we must put that machinery to work. We are moving from the setup phase to the architectural phase. Many authors mistakenly view ideation as a mystical process, waiting for inspiration to strike. In an efficiency-oriented workflow, however, ideation is a resource extraction process. It is about mining raw concepts and refining them into structural steel. We are not just brainstorming, we are blueprinting. This chapter focuses on the transition from abstract intent to concrete structure. You will learn to use recursive prompting to expand simple seeds into complex forests of ideas. We will then rigidly structure those ideas into cohesive plot beats for fiction or logical pedagogical progressions for non-fiction. Finally, we will apply engineering principles to stress test these structures before a single sentence of prose is written. 3.1 Recursive prompting for deep dive brainstorming. The most common failure mode in AI-assisted brainstorming is surface-level generation. If you ask a model for 10 book ideas about AI, you will receive 10 clichés. To generate novel concepts, you must force the model to dig deeper than its initial probabilistic tendencies. This requires a technique called recursive prompting. Recursive prompting is a looped workflow where the output of one generation becomes the constraint for the next. Instead of asking for a broad list, you ask for a list, select a specific vector, and force the model to expand solely on that vector. You are drilling down, not skimming across. Consider this workflow as a diamond mine. The first prompt clears the topsoil. The second prompt digs the shaft. The third prompt extracts the gems. You must guide the AI through these strata manually, or it will remain on the surface. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a vertical flow chart titled The Recursive Ideation Loop. Top layer, seed concept, broad circle. Middle layer, divergent generation, 3 distinct branches. Bottom layer, convergent selection, magnifying glass focusing on one branch. Arrows loop back from the bottom to the top labeled refinement iteration. Visual style, technical schematic, blueprint blue background with white lines, isometric perspective. The 3-step recursion protocol. To execute this, use the following protocol. Note how we explicitly forbid the AI from writing the story yet, we are only mining for the core concept. Step 1. Divergent generation. Ask for high variance options. Step 2. Selection and constraint. Pick the most interesting element and discard the rest. Step 3. Mutation. Ask the AI to generate variations of only that selected element. Here is the prompt syntax for Step 3, assuming you have already generated a list of concepts and selected option C. Context: we are refining the concept from option C, the protagonist is a cryptographer who decodes messages from a future timeline. Task: perform a deep dive mutation on this specific concept. Constraints: 1. Generate 5 distinct variations of this premise. 2. Vary the tone, authoritative, noir, hard sci-fi, and dystopian. 3. Do not resolve the conflict. Focus on the inciting incident. 4. Avoid tropes related to time machines or portals. Focus on signal theory. Output format: bulleted list with concept title and core conflict. By constraining the model to avoid specific tropes, time machines, and focus on a specific domain, signal theory, you force the probabilistic engine to look for less common token associations. This is where creativity occurs, in the constraints, not the freedom. 3.2 Generating cohesive plot beats and chapter arcs. Once you have a core concept, you must arrange it into a linear experience. For fiction authors, this means plot beats. The large language model, LLM, does not inherently understand pacing. It understands text prediction. If left unchecked, it will rush from the inciting incident to the climax in 3 paragraphs. To prevent this, we must act as the architect. We do not ask the AI to write a story. We ask it to construct a beat sheet. We are separating the what, events, from the how, prose. We rely on established narrative structures, such as the 3-act structure, Save the Cat, or Fichtean curves, to act as the scaffold. The AI is excellent at pattern matching. If you provide the structural pattern, it can fill the slots effectively. The event causality a chain. A major issue with AI plotting is a lack of causality. It often produces and then this happened, and then this happened. A strong plot requires this happened, therefore this happened. Use the following prompt structure to force causal links between your plot points. Role: Senior Narrative Designer. Task: create a 12-chapter outline for the concept defined previously. Constraint checklist. Strict adherence to the Dan Harmon story circle structure. Every chapter ending must create the problem for the next chapter. Define the value charge shift for each chapter, e.g., start positive, end negative. No dialogue. Summary of action only. Output format, markdown table. Chapter plot beat cause, input, effect, output, value shift. The table format is crucial here. By forcing the AI to fill a column labeled cause and effect, you programmatically ensure that the narrative flows logically. If a cell is weak, you can see the structural flaw immediately before you waste time writing the scene. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a horizontal timeline graph titled a narrative tension arc. The x-axis represents chapter progression 1 to 12. The y-axis represents a narrative tension. A line graph fluctuates, rising steadily. Key points are marked with icons: inciting incident, spark, midpoint, bridge, climax, and explosion. Below the graph, a causality chain shows linked chain links connecting each point. Visual style, minimalist data visualization, dark mode, neon accent colors. 3.3 Architecting non-fiction outlines with logical progression. For technical writers and non-fiction authors, the goal is not narrative tension but pedagogical transfer. Your structure must move the reader from a state of ignorance to a state of competence. This requires a different architectural approach, the logical hierarchy. When outlining non-fiction, we utilize the Mies principle, mutually exclusive, collectively exhaustive. This consulting framework ensures that your chapters cover the entire subject without overlapping. AI models are prone to repetition. The Mies principle is the antidote. You must command the AI to organize information based on user intent and complexity, rather than just topic clustering. The taxonomy prompt. To build a robust table of contents, to see, we instruct the AI to categorize ideas by complexity levels. This ensures the book has a learning curve that a human can actually climb. Context, we are writing a technical guide on a subject. Target audience, intermediate professionals. Task, develop a table of contents using Bloom's taxonomy as the structural guide. Structure constraints. Part 1, remember understand foundational concepts and terminology. Part 2, apply analyze workflows, tutorials, and practical implementation. Part 3, evaluate create advanced strategy and synthesis. Requirement. Ensure that no subtopic in Part 2 is introduced before its prerequisite concept is defined in Part 1. Verify logical dependency. Output, hierarchical markdown list. By invoking Bloom's taxonomy, you leverage a massive data set of educational theory present in the model's training data. This serves as a shortcut, instantly aligning the AI with a proven teaching structure. It prevents the common error of introducing advanced concepts too early. 3-point for stress testing narratives for holes and inconsistencies. The final stage of blueprinting is quality assurance, QA. In software engineering, code is tested before deployment. In efficiency-oriented authorship, the outline is tested before drafting. It is significantly cheaper to fix a plot hole in a bullet point than to rewrite 3 chapters of prose. We do this by assigning the AI a red team persona. A red team is a group attempting to break a system to find its vulnerabilities. We want the AI to become our harshest critic. This step is emotionally safe because the AI is criticizing the outline, not your finished writing. It allows you to view the work objectively, detaching your ego from the structural flaws. The devil's advocate simulation. Run your generated outline, fiction or non-fiction, through a stress test prompt. We want the AI to look for logic gaps, timeline errors, or weak arguments. Role, ruthless editor, logic consultant. Input, review the 12-chapter outline provided above. Task, identify the top 3 structural weaknesses. Look for 1. Deus ex machina resolutions, coincidences solving problems. 2. Character motivation inconsistencies, actions betraying established traits. 3. Logical leaps in non-fiction arguments, missing premises. Output format. Weakness identification. Why it fails. Suggested structural patch. Figure, Extra detailed AI-ready prompt for AI-generated diagram showing a heat map of structural integrity. A document icon is in the center. Red zones highlight specific paragraphs indicating logic gap or pacing drag. Green zones indicate strong cohesion. Call-out boxes pointed at red zones show alert icons. Visual style, HUD, heads-up display, interface, cybersecurity aesthetic, analytical and clean. If the AI points out that Chapter 7 relies on a coincidence, you fix the outline immediately. You add a setup in Chapter 3 that makes the event in Chapter 7 inevitable. This is the essence of structural blueprinting, solving problems upstream to ensure smooth sailing downstream. By the time you finish this chapter, you should not just have an idea. You should have a stress-tested, logically sound, engineered skeleton of your book. You have moved from a dreamer to an architect. In the next chapter, we will begin the process of pouring concrete, generating the actual prose that covers this steel frame.
Chapter 4, Character and World Database Management. Sections, Section 4.1, Synthesizing Detailed Character Profiles and Backstories, Section 4.2, Maintaining Consistency in World Building and Lore, Section 4.3, Engineering Distinct Voice and Dialogue Patterns, Section 4.4, Creating Dynamic Relationship Maps Using Structured Data. In Chapter 3, we treated the narrative structure as a blueprint, erecting the steel beams of your story through recursive outlining. However, an empty structure is lifeless. To transform a plot outline into a compelling narrative, you must populate it with agents, characters, and define the physics of the world they inhabit. In traditional writing, this is often a chaotic process involving scattered notebooks, mental maps, and disjointed Scrivener files. In the context of AI-assisted authorship, this approach leads to context drift. As the story progresses, the large language model, LLM, will inevitably forget eye color, confuse allegiances, or alter the rules of your magic system unless strict data governance is applied. We must stop viewing character sheets and world Bibles as mere reference documents. Instead, we must treat them as a structured database that is injected into the model's context window. This chapter defines the protocols for encoding creative assets into formats that LLMs can parse, retain, and act upon with high fidelity. 4.1 Synthesizing Detailed Character Profiles and Backstories. The most common failure mode in AI character generation is the regression to the mean. Without explicit, high-resolution constraints, an LLM will default to stereotypes found in its training data: the gritty detective, the damsel in distress, or the wise wizard. To prevent this, we must move beyond prose descriptions and utilize structured data schemas. We utilize a technique called attribute serialization. Rather than writing a paragraph about a character, we define them using key-value pairs. This reduces token usage while increasing the model's adherence to specific traits. It forces the model to treat the character as a collection of immutable constraints rather than a fluid creative suggestion. The following figure illustrates the conceptual shift from vague descriptions to structured schemas. Figure: a split-screen comparison diagram. On the left, a messy, handwritten notebook page titled Traditional Notes features crossed-out text and vague doodles of a character. On the right, a clean, holographic blue interface titled Serialized Character Schema shows a 3D wireframe head of the same character surrounded by floating data nodes labeled psychometrics, speech patterns, and physical vectors connected by laser-sharp lines. The lighting is cool and cybernetic, emphasizing precision. To implement this, we create a master character object. This is a standardized prompt block you will insert whenever a specific character enters a scene. Character_ID, Elara_Vance. Role, Antagonist Tech CEO. Physical_vectors. Height, 180 centimeters. Distinctive_feature, cybernetic ocular implant, left eye, glows red when stressed. Attire, utilitarian luxury, monotone colors, high collar. Psychometrics. Core_drive, order through surveillance. Fear, unpredictability chaos. Moral_alignment, lawful evil. Cognitive_style, algorithmic, detached, hyperrational. Narrative _ constraints. Never _ do. Apologize, show physical weakness, use contractions. Always _ do. Analyze risks aloud, maintain eye contact. By presenting the character in JSON format, or a similar structured markup, you signal to the model that these are rigid parameters. When you ask the AI to write a scene, you paste this block into the system prompt or the preamble. This ensures that Ilara Vance never apologizes and always maintains her detached cognitive style, regardless of the plot's chaos. 4.2 Maintaining consistency in world building and lore. World building suffers from the same entropy as character consistency. As a story expands, the physics of your world, whether magical rules, faster-than-light travel mechanics, or corporate hierarchies, tend to bend to suit the immediate needs of a scene. This creates plot holes that shatter reader immersion. To solve this, we implement a context anchoring system. You must distill your world building into a set of inviolable axioms. These are not merely background flavor, they are the logic gates through which the narrative must pass. If the AI attempts to generate a scene that violates an axiom, the prompt structure must force a correction. Effectively managing this requires separating your world data into two categories: static lore, history, rules of physics, and dynamic state, current political tension, resource levels. Data category definition, prompt implementation. Consider the following prompt structure for maintaining strict adherence to a hard magic system. This prompt acts as a validator before the scene is fully written. ***, direct instruction ***. Generate the upcoming scene based on the plot point provided. However, you must adhere to the following world axioms. If the narrative violates these axioms, revise strictly. World axioms ***. 1. Teleportation is impossible within city limits due to damping fields. 2. Currency is purely digital, physical cash is considered contraband. 3. The atmosphere is toxic, characters outside must wear filtration masks. Scene context ***. Characters A and B are fleeing the bank robbery. By explicitly labeling these as axioms, you provide the model with a rule set that overrides its tendency to use generic tropes, like a getaway car or running down an alley without a mask. You are acting as the compiler, ensuring the code of your story executes without logic errors. 4.3 Engineering distinct voice and dialogue patterns. One of the most distinct markers of AI-generated text is the homogenized voice. Without intervention, every character speaks with the same measured cadence, perfect grammar, and neutral tone. To engineer distinct voices, we must define the linguistic fingerprint of each character. This goes beyond simple adjectives like angry or shy. We must control specific linguistic levers, lexical density, sentence structure variance, and slang usage. A street urchin should have a different token probability distribution than a high elven scholar. We achieve this by assigning linguistic parameters to our character profiles. Figure: a detailed infographic displaying 3 audiovisual equalizer bars. Each bar represents a different character voice. The first is labeled the soldier with high bars for brevity and imperatives. The second is the scholar with high clause complexity and Latin's phrases. The third is the rogue with high slang and sentence fragments. The visual style is clean, vector-based, and technical. When prompting for dialogue, include a voice definition block like the one below. This instructs the AI to modulate its output style to match the specific character's fingerprint. Dialogue parameters: Jack the Hammer. Sentence length: short, truncated. Vocabulary level: basic, concrete nouns. Tone: aggressive, impatient. Tick: refers to people by their defining physical trait, e.g., slim, specs. Contractions: heavy usage, gonna, wanna, ain't. Dialogue parameters: Professor Aldous. Sentence length: long, compound complex sentences. Vocabulary level: academic, polysyllabic, abstract. Tone: condescending, lecturing. Tick: start sentences with conjunctions, however, furthermore. Contractions: zero usage. By feeding these parameters into the prompt immediately before requesting dialogue, you force the model to shift its predictive patterns. Jack will generate text like "move it," specs. "We ain't got all day," while Aldous generates "furthermore, it is imperative we proceed with caution, lest we disturb the delicate equilibrium." 4.4 Creating dynamic relationship maps using structured data. Characters do not exist in a vacuum, they exist in relation to one another. A common failure in long-form generation is the AI forgetting that two characters are currently feuding, or that they developed a secret alliance 3 chapters ago. To manage this, we borrow a concept from graph theory, the adjacency matrix. While we don't need to write complex math, we do need to track the state of relationships explicitly. We cannot rely on the ARI's context window to remember the emotional nuance of an interaction from 20,000 tokens ago. We maintain a relationship state log that is updated at the end of every chapter. This log acts as a snapshot of the emotional web connecting your cast. The relationship update workflow: 1. Generate scene, create the narrative text. 2. Analyze state, ask the AI to summarize changes in relationships based on that scene. 3. Update database, modify your master list of relationships. 4. Inject, paste the updated list into the next prompt. Here is the prompt format for tracking these dynamic vectors. Current_relationship_matrix. Duo, protagonist, rival. Status, hostile, escalating. Recent_event, rival stole the artifact in chapter 3. Trust_level, 0-10. Duo, protagonist, mentor. Status, strained. Recent_event, mentor withheld information about protagonist's father. Trust_level, 6/10, down from 9/10. This YAML style block is highly token efficient. It tells the AI exactly where the characters stand emotionally before the first word of the new chapter is generated. It ensures that the dialogue between the protagonist and the mentor reflects that specific strain, rather than reverting to a generic teacher-student dynamic. By implementing these 4 database management strategies: serialized profiles, world axioms, voice fingerprinting, and relationship matrices, you move from being a writer who hopes the AI remembers, to a director who ensures it never forgets. You are building a persistent, queryable world that serves as the solid foundation for the complex narrative architecture we will construct in the next chapter.
Chapter 5, The Drafting Phase, Iterative Text Generation. Sections: Section 5.1, Transforming Outlines into Prose, the Expansion Workflow. Section 5.2, Chain of Thought Prompting for Complex Scene Logic. Section 5.3, Managing Tone Drifts and Stylistic Continuity. Section 5.4, Strategies for Overcoming Context Window Saturation. We have spent the previous chapters acting as architects and engineers. We have understood the probabilistic mechanics of the engine, established a robust system architecture, blueprinted the narrative structure, and populated our database with characters. Now, the planning phase ends. It is time to enter the production phase. Drafting with artificial intelligence is not about pressing a button and receiving a finished novel. It is an iterative, granular process of expansion. If you attempt to generate a full chapter in a single prompt, the model will hallucinate, rush the pacing, and default to clichés. To maintain quality, we must treat drafting as a manufacturing workflow, expanding high-level outlines into prose through controlled, sequential steps. This chapter defines the protocol for iterative text generation. We will move away from the concept of writing in the traditional sense and embrace the role of a director guiding a performance. You will learn to expand beats into scenes, enforce logical consistency through chain of thought prompting, and manage the finite memory resources of the machine. 5.1 Transforming Outlines into Prose, the Expansion Workflow. The most common error in AI-assisted writing is prompt greed, asking for too much text at once. An LLM's quality degrades inversely to the length of the requested output. To maintain the specific voice and high density of information required for professional publishing, you must adopt a beat-to-prose expansion workflow. This workflow relies on the concept of interpolation. You provide the start state and the end state of a specific beat, a small unit of action, and the AI interpolates the narrative tissue connecting them. By limiting the scope of generation to 200 to 400 words at a time, you retain tight control over pacing and sensory details. Figure, a flowchart diagram titled the iterative expansion loop. The diagram shows a cyclical process. Step 1, input, single narrative beat, bullet point. Arrow to step 2, process, style-constrained expansion. Arrow to step 3, output, raw prose block. Arrow to step 4, human review and edit. Arrow to step 5, context update. The cycle returns to step 1 for the next beat. The visual style is clean, technical wireframe aesthetic, utilizing blue and gray tones. The following prompt structure is designed for this specific expansion task. Note how it separates the narrative instruction from the stylistic constraint. System role. You are a lead fiction writer specializing in genre. Your goal is to expand a specific narrative beat into high-quality prose. Context. Current scene, scene name and number. POV character, character name. Setting, location details from CH for database. Stylistic parameters. Show, don't tell, focus on sensory details, sight, smell, texture. Sentence structure, varied length. Avoid repetitive subject-verb starts. Tone, refer to tone definition from CH2. Forbidden phrases, a shiver went down his spine, palpable tension, unbeknownst to him. Input beat. Insert single outline bullet point here, e.g., Sarah enters the server room, noticing the humidity, and finds the rogue cable. Instruction. Write the prose for this specific beat only. Do not resolve the entire scene. Stop immediately after the action in the beat is concluded. By constraining the output to a single beat, you force the model to slow down. It cannot rush to the climax because it is forbidden from going beyond the current action. This results in narrative traction, where the reader feels the weight and texture of the scene. Once the output is generated, you, as the human operator, must perform a micro-edit. Fix hallucinations, tweak dialogue, and ensure the voice aligns with your intent. Only then do you feed the next beat into the prompt chain. This is not speed writing, it is precision assembly. 5.1.1 The accordion method. Think of your story as an accordion. The outline is the instrument fully compressed, the draft is the instrument fully expanded. Your job is to pull the bellows open one section at a time. If a generated section feels flat, do not rewrite it manually yet. Instead, ask the AI to zoom in. Prompt it to describe a specific object mentioned in the previous generation or to expand on a character's internal monologue regarding the action. This vertical expansion adds depth before you move horizontally to the next plot point. 5.2 Chain of thought prompting for complex scene logic. LLMs are probabilistic, meaning they guess the next word based on likelihood, not logic. In simple scenes, this works fine. However, in complex scenarios, such as a detective deducing a clue, a tactical combat sequence, or a nuanced political debate, probability often fails. The model might have a character shoot a gun they haven't drawn or reveal a secret they shouldn't know yet. To solve this, we utilize chain of thought, COT, prompting. This technique forces the model to show its work and plan the logic of the scene before generating the prose. It separates the logical computation from the creative generation. When you ask the model to think first, it allocates tokens to reasoning. This greatly reduces continuity errors and dream logic. Use the following template for scenes requiring high logical fidelity. Task, logical scene generation. Input context. Characters, list present characters. Objective, e.g., character A needs to convince character B to unlock the door without revealing he is a spy. Instruction. Step 1, the logic layer. First, outline the logical flow of the interaction in bullet points. Determine 1. The psychological state of each character. 2. The sequence of micro-actions required. 3. the logical cause and effect of the argument or physical action. Step 2. The narrative layer. Using the logic defined in Step 1, write the scene in prose. Ensure the dialogue matches the logical progression. By reviewing Step 1 in the output, you can catch logical flaws before reading the prose. If the logic is sound but the prose is weak, you can simply ask the model to rewrite Step 2 using the logic from Step 1 with a darker tone. You are debugging the plot separately from the prose. 5.3 Managing tone drifts and stylistic continuity. One of the most persistent challenges in AI drafting is tone drift. Over the course of a long session, an LLM tends to revert to its training mean, a bland, overly polite, or melodramatic corporate voice. It forgets the gritty noir style you established in Chapter 2 and begins sounding like a marketing brochure. To combat this, we must implement style injections at regular intervals. Relying solely on the initial system prompt is insufficient for long-form content. You need to remind the model of its stylistic constraints within the prompt loop itself. Figure, a graph visualizing tone drift over time. The y-axis represents stylistic adherence, 0 to 100, and the x-axis represents token count time. A line starts high at 100, slowly dipping as tokens increase. Vertical markers indicate style injection points where the line spikes back up to 100. The visual should look like a system performance monitor overlay. We can categorize common AI stylistic failures and their specific prompt antidotes in the table below. Use these as negative constraints in your prompts. Type of drift symptoms prompt antidote, negative constraints. In practice, if you notice the prose becoming purple, stop immediately. Do not edit it yourself yet. Feed the last paragraph back to the AI with the instruction, rewrite this paragraph. Strip all adjectives. Focus on the physical sensation of the cold. Reduce sentence length by 30%. This correction shot retrains the context window on the correct style before you proceed to the next beat. It saves you from having to rewrite thousands of words later. 5 Point for strategies for overcoming context window saturation. The context window is the amount of text the AI can see at one time. While modern models have large windows, filling them with the entire history of your book creates noise. When the context is saturated with irrelevant details from Chapter 1, the model struggles to focus on the nuance of Chapter 15. To maintain efficiency, we use a rolling context strategy. You do not feed the whole book into the chat. You feed only what is strictly necessary for the current scene. 5 Point for Point 1 The sliding window protocol. Imagine driving a car at night. You only need to see the road illuminated by your headlights, the current scene, and remember the route you just took, the immediate summary. You do not need to see the driveway you left 3 hours ago. The static base, this is your system prompt plus character database, CH2 and 4. This is pinned or repeated in every session. The previous summary, a 200-word synopsis of the immediately preceding chapter or scene. The active text, the last 500 to 1,000 words of prose you generated. When you finish a chapter, do not leave it in the chat window. Copy the text to your master document, Scrivener Word. Then, ask the AI to summarize that chapter. Task, context compression. Summarize the text above into a bulleted list of factual events, key items acquired, and changes in character relationships. Do not include flowery language. Pure data. Take this summary and use it as the previous summary for your next drafting session. This keeps the AI's attention sharp and prevents the latency of logic that occurs when the model tries to parse too much data. By managing your context window like a strict budget, you ensure that the model's processing power is dedicated to creativity, not memory retrieval. You are keeping the engine light and responsive.
Chapter 6. Technical Writing and Non-Fiction Specifics. Sections. Section 6.1. Summarization and Synthesis of Complex Research Materials. Section 6.2. Structuring Instructional Content and Tutorials. Section 6.3. Fact Verification Protocols and Hallucination Mitigation. Section 6.4. Formatting Output for Markdown, LaTeX, and Code Blocks. In the previous chapters, we focused heavily on the mechanics of narrative construction, building worlds, tracking characters, and expanding creative prose. However, for many of you, the primary utility of large language models, LLMs, lies not in fiction, but in the rigorous domain of non-fiction. Whether you are writing technical documentation, a history book, or an instructional guide, the rules of engagement change drastically here. In fiction, the goal is plausibility. In technical writing, the goal is veracity and clarity. An LLM's tendency to hallucinate, a quirk we sometimes harness for creativity in Chapter 3, becomes a liability in non-fiction. You cannot afford for the model to invent a Python library or misquote a historical figure. Consequently, this chapter shifts our system architecture from creative expansion to analytical constraint. We will treat the LLM less like a co-author and more like a junior analyst and typesetter. You will learn to force the model to synthesize dense research, structure tutorials for maximum retention, rigorously check its own work, and output code-perfect formatting that saves you hours of typesetting. 6.1 Summarization and synthesis of complex research materials. The greatest strength of an LLM in a non-fiction workflow is its ability to process semantic density faster than a human. However, asking a model to simply summarize this text often yields generic, surface-level results. To get usable synthesis for a book, you must guide the model's attention mechanism to specific layers of information. We must distinguish between summarization, shortening text, and synthesis, combining multiple sources into a new insight. Summarization is compression, synthesis is alchemy. To achieve high-quality synthesis, you should use an iterative approach I call the extraction-integration loop. First, do not paste 10 pages of text and ask for a chapter draft. Instead, instruct the model to extract key assertions, data points, and logical arguments into a structured list. Once the raw data is isolated from the noise of the source prose, you can feed those assertions back into the model to generate your content. This reduces the risk of the model glossing over nuance. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a data pipeline workflow. On the left, a stack of disorganized documents labeled raw input. In the center, a funnel mechanism labeled semantic extraction filtering distinct glowing data points. On the right, these points are reassembled into a structured hexagonal grid labeled synthesized output. The style should be isometric, clean vector art, using a blueprint blue and technical white color scheme, emphasizing logic and order. Use the following prompt structure to force the model to prioritize synthesis over simple regurgitation. Hash role. Act as a senior technical editor. Hash input data. Insert research text here. Hash task. 1. Extract the top 5 distinct technical claims or arguments from the text. 2. For each claim, preserve the original terminology but simplify the explanation for a target audience. 3. Identify any logical gaps or undefined variables in the source text. 4. Synthesize these points into a coherent 200-word insight block. Do not use bullet points for the final output, use transitional prose. By explicitly asking for logical gaps, step 3, you force the model to analyze the text critically rather than passively accepting it. This turns the LLM into a research assistant that alerts you to missing information before you start writing. 6.1.1 Handling context window limitations. When dealing with full-length books or massive technical manuals, you will inevitably hit the context window ceiling. While modern models handle large contexts, accuracy degrades as the window fills, a phenomenon known as lost in the middle. To combat this, chunk your input data logically, not just by character count. Split research materials by topic or argument rather than arbitrary page numbers. Process these chunks individually to extract the core metadata, then combine those extractions for your final synthesis. This ensures that a crucial statistic on page 40 isn't forgotten because the model was overwhelmed by page 1. 6.2 Structuring instructional content and tutorials. Technical writing relies heavily on instructional design. If you are writing a how-to book, your goal is cognitive ease. The reader should not have to struggle to understand the sequence of actions. LLMs, left to their own devices, often mix declarative knowledge, what something is, with procedural knowledge, how to do it. We must impose a strict separation of these modes. When generating tutorials, use a state-action-result framework. This forces the model to describe the starting state, the specific action required, and the expected outcome for every step. This prevents the vague instructions often seen in AI-generated guides. Figure, extra detailed AI-ready prompt for AI-generated diagram illustrating the state-action-result loop. A circular flowchart with 3 distinct nodes. Node 1 state shows a computer terminal icon. Arrow points to node 2 action showing a keyboard input icon. Arrow points to node 3 result showing a checkmark on a screen. The background is a dark technical grid. The style is flat, modern UI design, utilizing high-contrast neon green and dark gray. Here is a prompt designed to generate robust tutorial steps. Hash instructional protocol. You are writing a tutorial for subject. Adhere to the following formatting rules for every step. 1. Context***. Briefly explain why we are taking this step. 2. Action***. Provide the exact command, click path, or physical action. Use bold text for UI elements. 3. Validation***. Tell the reader exactly what they should see on screen after the action. 4. Troubleshooting***. Anticipate one common error at this stage and provide a one-sentence fix. Create step 4 of the tutorial covering specific task. This structure ensures that your reader is never left wondering if they did the right thing. The validation step is critical, it gives the reader confidence to proceed. The troubleshooting component adds significant value, making your book feel like it was written by an experienced mentor who knows where students typically stumble. 6.3 Fact verification protocols and hallucination mitigation. In Chapter 3, we discussed temperature settings to control creativity. In technical nonfiction, we want the temperature near 0, but even that is not a guarantee of truth. Hallucinations in nonfiction are insidious because they often sound highly plausible. An LLM might invent a citation that looks real, using a real author's name and a believable title, but the book does not exist. To mitigate this, you must adopt a zero-trust architecture with your AI. Never ask the AI to provide a fact without also asking it to grade its confidence or provide a retrieval path. If you are using an LLM with web browsing capabilities, explicitly instruct it to verify its claims against live data. However, for offline drafting, use the adversarial critic method. After generating a section of technical content, start a new chat session or use a distinct separator in the current context. Ask the model to critique its own previous output specifically for factual accuracy. #adversarial review. Review the text provided above. Act as a skeptical fact-checker. 1. List every proper noun, date, statistic, and citation used in the text. 2. Assign a confidence score, 0 to 100%, to each item based on your internal training data. 3. Flag any statement that relies on inference rather than explicit knowledge. 4. If a citation is used, output the DOI or URL format if known. If not known, flag as requires manual verification. This process does not guarantee 100% accuracy, but it highlights the risk areas. It forces the model to break the flow of text generation and switch to analysis mode. You, as the author, must then manually verify the flagged items. This turns fact-checking from a needle-in-a-haystack search into a targeted checklist. 6.3.1 The citation trap. Be wary of asking LLMs to generate bibliographies from scratch. They are notorious for creating chimera citations, combining a real author with a real journal but a fake article title. Instead, supply the bibliography to the model first. Paste your list of verified references into the context window. Then, instruct the model, use only the provided references to support the following arguments. Do not introduce outside citations. This creates a closed-loop system where the AI formats and inserts citations, but you control the source of truth. 6.4 Formatting output for Markdown, LaTeX, and code blocks. Efficiency in technical writing isn't just about word count, it's about interoperability. If you are writing a book on mathematics or programming, manually formatting equations or code snippets in Word is a bottleneck. We can program the LLM to output content in syntax-perfect Markdown, LaTeX, or specific code block formats that convert cleanly into publishing software like Vellum, InDesign, or Pandoc. By defining output schemas, you save hours of post-processing. For example, if you are writing a coding book, you want code blocks to include language identifiers for syntax highlighting. If you are writing scientific papers, you want math formatting that renders correctly. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a syntax conversion engine. Visual shows raw text entering a prism and splitting into 3 distinct colored streams. Stream 1 is labeled Markdown with hash symbols. Stream 2 is labeled LaTeX with sigma and integral symbols. Stream 3 is labeled Code with brackets and tags. The aesthetic should be sleek, cybernetic, and glowing, representing data transformation. Here is how to set up a system prompt for handling mixed media technical content. Hash output formatting rules. You are a technical typesetter. All output must adhere to these strict rules. 1. Headers ***. Use standard Markdown, ## for H2, ### for H3. 2. Code ***. All code must be inside triple backticks with the language specified, e.g., Python. 3. Math ***. All mathematical formulas must be in LaTeX format enclosed in single $signs for inline, e.g., $e = MC$2, and double $signs for block, e.g., $. 4. Key terms ***. Bold the first instance of any technical term defined in the glossary. 5. Callouts ***. Format warnings or tips using block quotes, ***note ***. Do not render the result. Output the raw Markdown code. Using this approach allows you to copy the raw output directly into a Markdown editor, like Obsidian or VS Code, or convert it via Pandoc to a perfectly formatted docx file. This bypasses the erratic formatting behavior of standard word processors. 6.4.1 Tables and data representation. LLMs struggle with visual spacing in plain text, but they excel at Markdown tables. If you need to compare features or present data, explicitly request a Markdown table. This ensures that when you import the text into your layout software, the columns and rows are preserved structurally. For complex data visualization that an LLM cannot render, like charts, instruct the model to output a figure placeholder description similar to the ones used in this chapter. This keeps your writing flow uninterrupted, leaving a clear specification for the diagrams you need to create or commission later.
Chapter 7, The Automated Editor, Critique and Refinement. Sections, Section 7.1, Prompting for Structural Analysis and Pacing Assessment, Section 7.2, Identifying Passive Voice, Repetition, and Weak Verbs, Section 7.3, Simulating Reader Demographics for Targeted Feedback, Section 7.4, Line Editing Workflows, Grammar, Syntax, and Clarity. In Chapter 5, we engineered a production line for drafting, focusing on the iterative expansion of prose. In Chapter 6, we tightened those constraints for the rigorous demands of technical nonfiction. Now, we arrive at the most grueling phase of the publishing lifecycle, editing. To the unassisted author, editing is an emotional minefield. It requires you to switch mental gears from the creator, who nurtures ideas, to the critic, who ruthlessly culls them. This cognitive dissonance creates friction, often leading to procrastination or blindness to one's own errors. In an efficiency-oriented AI workflow, we solve this by outsourcing the role of the critic. We do not use the AI to simply fix the text, which often results in bland, homogenized prose. Instead, we program the AI to act as a diagnostic engine. It identifies structural weaknesses, pacing issues, and stylistic drift, presenting you with data rather than decisions. This chapter details how to configure your system to act as a merciless editor. We will move beyond simple grammar checks and build prompts that analyze narrative tension, identify passive anomalies, and simulate specific reader demographics to stress test your manuscript before it ever reaches a human set of eyes. 7.1 Prompting for structural analysis and pacing assessment. When you are deep in the trenches of a chapter, you lose perspective on the global narrative arc. You might write a beautiful scene, but fail to notice that it halts the story's momentum. Traditional editing requires you to cool off for weeks to regain objectivity. AI allows us to regain that objectivity instantly through structural analysis. We use a technique called reverse outlining. Instead of telling the AI what the story should be, we feed it the drafted text and ask it to summarize the structural beats it detects. If the RA's summary diverges from the blueprint you created in Chapter 3, you know the drafting phase failed to convey your intent. You must specifically prompt for pacing metrics. Pacing is not just a feeling, it is the ratio of information delivery to word count. In action scenes, this ratio should be high. In introspection, it can be lower. Use the following prompt to diagnose a scene's structural health. Role: structural editor. Input: pace scene text here. Task: analyze the structural integrity and pacing of the provided text. Output requirements. 1. Reverse outline. Summarize the scene in 3 bullet points. What actually happened? 2. Pacing graph. Assign a attention score, 1 to 10, to the beginning, middle, and end. 3. Beat analysis. Identify the turning point where the value charge of the scene shifts, e.g., from positive to negative. 4. Diagnosis. Does the pacing drag? Highlight sections where the word count exceeds the informational value. Figure. Extra detailed AI-ready prompt for AI-generated diagram showing a attention heat map overlay on a manuscript page. The visual should depict a document page on the left, and on the right, a vertical waveform graph colored in gradients from cool blue, low tension, to hot red, high tension, corresponding to specific paragraphs. Callouts point to slow pacing detected in blue zones and a climax peak in red zones. Style: clean, minimal UI interface, dark mode aesthetic. If the AI identifies the turning point in the first paragraph, your scene has peaked too early. If it cannot identify a value shift, the scene is likely filler. This objective feedback loop allows you to cut scenes that do not advance the plot, regardless of how well written the prose might be. 7.2 Identifying passive voice, repetition, and weak verbs. One of the greatest risks in AI-assisted writing, and human writing, frankly, is the creeping reliance on passive voice and filter words. Filter words, e.g., he felt, she saw, it seemed, place a layer of distance between the reader and the experience. Standard grammar checkers are binary, they mark text as correct or incorrect. Large language models offer a semantic advantage, they understand nuance. However, if you simply ask the AI to rewrite this to be active, it will often strip away your unique voice and replace it with corporate-safe neutrality. The superior workflow is identification, not correction. We prompt the model to act as a highlighter, extracting the offending phrases into a table. This puts the editorial decision back in your hands, ensuring the manuscript retains your authorial fingerprint while highlighting technical flaws. Use this constraint-based prompt to audit your prose. Role: copy editor. Constraint: do not rewrite the text. Only list issues. Task: audit the text for zombie nouns, nominalizations, passive voice, and filter words. Output format: markdown table. Issue type: original phrase, why it weakens the prose suggested alternative, active strong. Passive voice: the ball was thrown by him hides the actor he threw the ball. Filter word: she felt the cold wind creates distance, the cold wind bit her skin. Weak verb: he went quickly to the door. Adverb: reliance, he bolted to the door. By reviewing this table, you can decide which instances serve a stylistic purpose and which are simply lazy writing. You maintain control. The AI serves only to reduce the signal-to-noise ratio of your self-editing process. 7.3 Simulating reader demographics for targeted feedback. In Chapter 2, we discussed defining a persona for the writer. Now, we invert that architecture to define a persona for the reader. A technical manual requires a different critique than a young adult fantasy novel. A general critique. This prompt will yield generic advice. To get actionable feedback, you must simulate your target audience. If you are writing a technical guide for beginners, see Chapter 6, you need a naive reader persona who flags jargon. If you are writing a thriller, you need a bored reader persona who flags slow starts. This simulation acts as a rapid beta reading round. It exposes blind spots that you, as the expert of your own world, cannot see. You know how the magic system works, the reader does not. Here are 3 distinct reader simulations to plug into your workflow. The skeptic, non-fiction or technical. Adopt the persona of a skeptical industry professional. You doubt unproven claims and hate marketing fluff. Read the following section and flag any assertion that lacks evidence or feels like hyperbole. The confused newcomer, instructional complex fiction. Adopt the persona of someone completely new to this topic and genre. Highlight any terms, acronyms, or world-building concepts that are introduced without context. Tell me where you feel lost. The impatient browser, commercial fiction or web copy. You are a reader with a short attention span browsing on a mobile device. Identify the exact sentence where you would stop reading because you got bored. Be harsh. Figure, extra detailed AI-ready prompt for AI-generated diagram showing 3 distinct reader profile cards. Card 1, the skeptic, icon of a monocle, magnifying glass, stats for logic, high, patience, low. Card 2, the newcomer, icon of a question mark, open hand, stats for context need, high. Card 3, the impatient, icon of a stopwatch to scrolling finger, stats for attention span, critical. The background should look like a sleek dashboard selecting a simulation mode. Running your draft through these diverse simulators provides a triangulation of feedback. If the skeptic and the newcomer both flag the same paragraph, you have a definitive problem area that requires immediate revision. 7.4 Line editing workflows, grammar, syntax, and clarity. Once the structure is solid and the stylistic patterns are addressed, we move to the final stage, line editing. This is the microscopic view. In traditional publishing, this is the most expensive phase because it requires intense human focus. For the efficiency-oriented author, the danger here is hallucination of errors. Sometimes an LLM will fix a sentence that was already correct, simply because the model prefers a different syntax. To mitigate this, we must use a differenced workflow, derived from software development, where we compare the original against the proposed change. We also need to enforce a style guide. Whether you use the Chicago Manual of Style, CMOS, or the Associated Press, AP, style depends on your genre. The AI needs to know the rules of engagement before it touches a comma. Execute the following workflow for the final polish. Define the standard, establish the rule set, e.g., Oxford comma usage, capitalization rules for headers. The difference prompt, ask the AI to rewrite the paragraph for clarity, but compel it to explicitly state what it changed and why. Role, line editor. Style guide, Chicago Manual of Style, 17th ed. Tone, professional, concise, authoritative. Task, polish the following text for grammar, syntax, and flow. Output format. 1. Revised version. 2. Changelog, list every change, changed utilize to use for brevity. By forcing the changelog, you prevent the AI from making silent, unnecessary alterations. You can scan the log. If you see a change you disagree with, perhaps a dialect you want to preserve, you can reject it immediately, stet. This method transforms line editing from a tedious read-through into a rapid approval process. You are no longer hunting for typos, you are approving a list of corrections. This shift in workflow dramatically reduces the cognitive load of the final polish, ensuring your energy is reserved for the creative architecture of the next book.
Chapter 8, Visual Assets and Multimodal Integration. Sections, Section 8.1, Constructing Prompts for Cover Art and Concept Visuals, Section 8.2, Designing Diagrams and Infographics via Text Descriptions, Section 8.3, Maintaining Visual Consistency Across Book Series, Section 8.4, Preparing alt text and metadata for accessibility. In the previous chapters, we rigorously engineered your text. We established structural blueprints, Chapter 3, populated databases, Chapter 4, and refined the prose through automated critique, Chapter 7. You have mastered the manipulation of language. Now, we must expand your capabilities into the visual spectrum. Modern publishing is inherently multimodal. Whether you are an independent novelist requiring cover art or a technical writer needing architectural diagrams, the ability to generate visual assets on demand is a force multiplier. We are moving beyond the role of the writer. You are now acting as the creative director of your own production studio. This chapter details the workflow for integrating visual generation into your authorship stack. We will not treat image generation as a novelty or a toy. Instead, we will approach it with the same engineering mindset we applied to text, constructing precise prompt payloads to achieve consistent, high-fidelity results that align with your narrative or technical goals. Section 8.1, Constructing Prompts for Cover Art and Concept Visuals. The cover of your book is not merely decoration, it is metadata. It signals genre, tone, and production value to the prospective reader before they read a single word. When using AI for visual generation, we face the challenge of semantic interpretation, the model's tendency to focus on the wrong part of a complex description. To generate effective cover art, you must decouple the subject from the style. Many authors fail by writing prompts that read like book summaries, a story about a sad boy in 1920s London. Image models do not understand narratives, they understand composition, lighting, and texture. You must translate your narrative themes into visual primitives. We utilize a layered composition prompt structure. This involves specifying the medium, subject, environment, lighting, and color palette as distinct tokens. This reduces the noise in the diffusion process and prevents the model from conflating the emotional tone with the physical lighting. Prompt template, the layered composition. Medium, digital oil painting, hyperrealistic book cover art. Subject, close-up profile of a weathered cyberpunk detective, glowing cybernetic eye, stoic expression. Environment, rainy neon-lit alleyway, blurred background city elements. Lighting, high-contrast chiaroscuro, volumetric fog, teal and orange rim lighting. Style, matte painting, art station trending, intricate detail, rule of thirds. Exclusions, text, blurry, distorted hands, watermark, low resolution. Parameters, R2:3v 6.0. Notice the specific aspect ratio, R2:3. This is standard for book covers. By defining this early, you ensure the composition fits the vertical slice required for Kindle or print, preventing the need for awkward cropping later. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a side-by-side comparison of a bad prompt result, cluttered, wrong ratio, and a layered composition result, clean focal point, correct aspect ratio, distinct lighting layers. The visual should look like a UI overlay analyzing the image structure. Section 8.2, Designing Diagrams and Infographics via Text Descriptions. For technical authors and non-fiction writers, generative pixel art, like DALL-E or Midjourney, is often insufficient for diagrams. These models struggle with text rendering and precise logical relationships. If you ask a diffusion model for a flowchart, it will likely hallucinate nonsensical shapes and gibberish text. The efficiency-oriented solution is to use the LLM to generate code for diagrams, not the image itself. We utilize text-to-diagram syntax languages like mermaid.js or plant.uml. This ensures that your diagrams are vector-based, editable, and logically accurate. By prompting the LLM to convert a textual concept into code, you maintain absolute control over the data presentation. You can edit a node in the text rather than trying to fix a flattened JPEG. This integrates perfectly with Markdown-based writing workflows. Prompt strategy, concept to mermaid syntax. Act as a technical illustrator. Context, I am writing a chapter on data flow in API architecture. Task: convert the following explanation into a valid mermaid.js flowchart syntax. Orientation: top-down, TD. Style: use square rectangles for processes and diamonds for decision points. Explanation to convert. The user sends a request. If the token is valid, the server queries the database. If the token is invalid, it returns a 403 error. After the database query, the data is formatted and sent back to the user. The LLM will output a clean code block. You then render this code using a markdown editor or a plugin. This method eliminates the frustration of trying to get an image generator to spell API correctly. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a split screen. On the left, the raw mermaid.js code block with syntax highlighting. On the right, the rendered vector flowchart showing the API logic cleanly. The background should be a dark mode IDE interface. Section 8.3: Maintaining visual consistency across book series. One of the most difficult challenges in AI art direction is character drift. You might generate a perfect protagonist for Chapter 1, but by Chapter 5, the model generates a person with a different bone structure or costume. For a professional product, consistency is non-negotiable. To solve this, we use seed locking and reference anchoring. A seed is the numerical starting point of the random noise generation. By keeping the seed constant, you limit the variance. However, seeds alone are rarely enough. You must also build a visual style guide, VSG, prompt segment that you append to every generation request. Do not rely on the model's memory of previous chats to maintain consistency. You must re-inject the character's definition in every prompt. Treat your character description like a reusable code variable. Workflow: the character anchor block. Define the anchor. Create a concise, unchanging description of the character's physical traits, e.g., sharp jawline, scar over left eyebrow, silver hair in a bun. Generate the reference. Create the master image. Save the URL or file path. Prompting with reference. Use the reference image as an input, image to image, alongside the text prompt to constrain the generation. Prompt example with reference injection. Image source: URL_master_character_reference. Text prompt: a photo of anchor_description, sitting in a dimly lit tavern, holding a map. Style consistency: same lighting and film grain as reference image. Weighting: IV2, high image weight to prioritize facial consistency. This approach allows you to place the same actor in different scenes without them morphing into a stranger. It requires discipline to manage your asset library, but it is the only way to build a cohesive visual brand for a series. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a character consistency pipeline. 3 images of the same character in different poses clothes, connected by a thread indicating a shared seed and reference image. The visual style should be schematic and clean. Section 8.4: Preparing alt text and metadata for accessibility. A truly professional book is accessible to all readers, including those using screen readers. In the past, writing alt text, alternative text, for images was a tedious manual chore. In our efficiency-oriented workflow, we reverse the direction of our AI pipeline to automate this. We utilize vision language models, such as GPT-4 Vision or similar multimodal tools, to analyze our generated images and produce compliant metadata. This is not just about accessibility, it is also crucial for SEO, search engine optimization, if your book has a web component. Do not use generic descriptions. Configure the AI to describe the image specifically in the context of your chapter. The alt text for a diagram of a network topology should describe the data flow, not just say a picture of a chart. Prompt for generating alt text. Role: accessibility specialist. Task: analyze the attached image and write WCAG-compliant alt text. Context: this image appears in a chapter about cybersecurity protocols. Requirements: 1. Be concise, under 125 characters if possible, or provide a long description. 2. Focus on the information conveyed, not just the artistic style. 3. Do not start with image of or picture of. By integrating this step immediately after asset generation, you prevent a compliance debt pileup at the end of the project. You ensure that your visual assets are as rigorously engineered and inclusive as your text. We have now successfully integrated the visual dimension into your authorial stack. You are capable of generating covers, technical diagrams, and consistent character art, all while maintaining accessibility standards. The Lone Writer is now a multimedia production team.
Chapter 9: Marketing, Metadata, and Discovery. Sections: Section 9.1 Reverse Engineering Algorithm-Friendly Book Blurbs, Section 9.2 SEO Strategy, Generating High-Value Keywords and Categories, Section 9.3 Automating Social Media Content Calendars and Ad Copy, Section 9.4 A/B Testing Titles and Hooks with Comparative Analysis. We have spent the last 8 chapters acting as architects, engineers, and editors. You have built a robust database, drafted manuscript text through iterative expansion, and generated professional visual assets. By all technical definitions, you have a product. However, in the digital marketplace, a product that cannot be found is effectively non-existent. Many authors view marketing as a separate, often dreaded, creative endeavor that begins only after the book is finished. This is a workflow inefficiency. In our system, marketing is not an artistic afterthought, it is a data engineering challenge. Just as we engineered the prose, we must now engineer the metadata that allows algorithms to surface your work to the right readers. The same large language models, LLMs, that helped you draft your chapters are exceptionally skilled at understanding semantic relationships and pattern matching, the exact mechanics behind search engines like Amazon and Google. We will not use AI to spam the market. Instead, we will use it to optimize your book's discoverability signals, ensuring it lands in the hands of the readers who need it most. This chapter transitions your role from creative director to chief marketing officer. We will automate the generation of high-conversion sales copy, identify semantic keywords that human research often misses, and build a content engine that sustains visibility without consuming your writing time. Section 9.1 Reverse Engineering Algorithm-Friendly Book Blurbs. A book blurb serves 2 distinct masters, the human reader and the retailer algorithm. The reader needs emotional hooks and clear stakes, the algorithm needs keywords and categorical relevance. Most authors struggle to balance these, resulting in dry summaries that neither convert humans nor attract search bots. We solve this by treating the blurb not as a summary, but as a conversion script. We can prompt the LLM to analyze the structure of best-selling blurbs in your specific subgenre and map your narrative elements onto that successful framework. This is style transfer applied to marketing copy. First, you must understand that a synopsis is chronological, but a blurb is psychological. We need to prompt the AI to ignore the ending and focus entirely on the conflict and the inciting incident. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a side-by-side comparison of a synopsis structure versus a blurb's structure. The synopsis side should show a linear timeline arrow labeled chronological. The blurb side should show a funnel shape labeled psychological hook, narrowing down to a call to action. Visual style should be clean, infographic vector art, blue and gray color scheme, appropriate for a technical manual. To generate a high-conversion blurb, we do not simply ask the LLM to write a description. We feed it the specific rhetorical devices found in top-tier advertising. Use the following workflow to generate blurb variations. Input: your detailed synopsis, from Chapter 3. Constraint: the specific hook body cliffhanger structure. Style: high stakes, active voice, keyword dense. Act AS, a senior copywriter for a major publishing house. Context: I have a technical thriller novel. Input: insert Chapter 3 synopsis. Task: write 3 variations of a back cover book blurb, approximate 200 words. Requirements: 1. Variation A, the questions start with a what-if scenario. Focus on high concept stakes. 2. Variation B. The character focus on the protagonist's internal conflict and external threat. 3. Variation C. The mystery focus on the central puzzle. Constraints. Use short, punchy paragraphs, 1 to 2 sentences. Include high-value keywords related to cybersecurity, AI, corporate espionage. End with a compelling hooky cliffhanger. Do not summarize the ending. Once you have these outputs, do not accept them blindly. You must analyze them for keyword density, the ratio of searchable terms to filler words. Refine the output by asking the LLM to highlight the power words in bold. If a blurb lacks highlighted terms, it is too passive. This objective analysis prevents you from falling in love with poetic but ineffective copy. Section 9.2 SEO Strategy: Generating High-Value Keywords and Categories. Discovery on platforms like Amazon is driven by semantic search. A reader might not search for your book's title, they will search for the problem they want to solve or the feeling they want to experience. Humans are often bad at guessing these search terms because we suffer from the curse of knowledge. We know too much about our own book. LLMs excel here because they have been trained on the entire Internet's corpus of associations. They can identify lateral keywords, terms that are semantically related to your topic but not immediately obvious. For non-fiction, we look for outcome-based keywords. For fiction, we look for trope-based keywords. Non-fiction strategy: readers don't search for Python guide, they search for automate Excel with Python or data science career shift. Fiction strategy: readers search for flavors, not ingredients. They search for enemies to lovers space opera or to cozy mystery with cats. Use the following prompt to build a master keyword list. Note how we ask the AI to categorize the intent behind the search. Context: my book is about. Topic: genre. Task: generate a table of 30 potential search keywords, phrases. Columns. 1. Keyword phrase. 2. User intent: what problem are they solving, what feeling do they want? 3. Category: broad versus niche. Strategy: include 10 short-tail keywords, broad, high competition. Include 20 long-tailed keywords, specific, lower competition, high conversion. For non-fiction, focus on how-to and specific outcomes. For fiction, focus on specific tropes and subgenres. Crucial warning: LLMs cannot see live data. They cannot tell you the current search volume or competition score of a keyword on Amazon today. They provide the semantic ideas, but you must validate these ideas using external tools, like Publisher Rocket or KDP Spy, or manual search bar autocomplete validation. Think of the LLM as your brainstorming partner who provides the raw list. Your job is to verify which of those keywords actually have traffic. This hybrid approach, AI for ideation, human for verification, is the most efficient path to optimization. Section 9.3 Automating social media content calendars and ad copy. Consistency is the hardest part of social media marketing for authors. You would rather be writing the next book than tweeting about the current one. The solution is to create a content waterfall. We take the high-effort asset, the book, and fracture it into low-effort micro-content. We can automate the extraction of tweetable moments, LinkedIn articles, or newsletter segments directly from your drafted manuscript. This ensures your marketing content is always aligned with your book's actual voice because it derives directly from the source text. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a content waterfall flowchart. Top box is labeled Source Chapter. Arrows flow down to 3 boxes: Newsletter, Summary, Twitter Thread, Key Insights, and Instagram TikTok Script, Visual Hook. The visual style should be a clean, modern process diagram with icons representing the different platforms, utilizing a monochromatic green palette to signify growth marketing. Here is a workflow to generate a week's worth of content from a single chapter. Select a chapter, choose a chapter that contains a strong lesson, non-fiction, or a distinct scene, fiction. Define the platform, the tone must shift. LinkedIn requires professional insight, TikTok requires a visual hook, Twitter requires threads. Input, paste text of Chapter 5. Task, repurpose this text into social media content. Output 1, a 5-tweet thread summarizing the key lesson. Hook, start with a contrarian statement. Body, 3 key takeaways. End, link to book. Output 2, a 200-word LinkedIn post. Tone, professional, authoritative. Focus, the workflow efficiency gained by this method. Output 3, a 30-second video script for TikTok Reels. Visual cue, describe what is on screen. Audio, script lines. By batch processing your marketing content, you separate the churn of social media from your daily writing routine. You can generate a month's worth of posts in a single afternoon session. Regarding advertising copy, Facebook, Amazon ads, we use the AI to iterate on established marketing frameworks like AIDA, attention, interest, desire, action, or PAS, problem, agitation, solution. Do not ask for one ad. Ask for 10, each targeting a different reader pain point. In marketing, quantity of variation leads to quality of data. Section 9.4, A/B testing titles and hooks with comparative analysis. The title of your book is the single most important metadata field. A bad title will kill a good book. Traditionally, authors ask friends or family for opinions, but this data is biased. In our workflow, we simulate a focus group using the LLM. While an LLM cannot predict market trends with 100% accuracy, it is excellent at comparative analysis. It can explain why Title A might sound more authoritative than Title B based on linguistic patterns found in your genre. We can create personas to test our hooks against. If you are writing a technical guide for beginners, a title that appeals to an expert might be a failure. We must test for alignment. Act AS, a frustrated beginner in field genre. Traits, impatient, overwhelmed by jargon, looking for quick wins. Task, review these 5 potential book titles, subtitles. 1. Title A. 2. Title B. Analysis. Which title do you click first? Which title intimidates you? Which title promises the clearest benefit? Rank them 1 to 5 and explain your reasoning in the first person. Run this prompt multiple times with different personas, e.g., the skeptical expert, the busy professional. This provides you with a spectrum of reactions before you ever launch the book. You can apply this same logic to your hook, the first sentence of your description. Ask the LLM to perform a boredom check. Prompt, analyze the following 5 opening sentences. Assign a boredom score from 0 to 10. If the score is above 3, rewrite the sentence to start closer to the action. By rigorously testing your metadata against simulated audiences, you minimize the risk of launching into the void. You are not guessing, you are making informed decisions based on simulated feedback loops. We have now successfully bridged the gap between creation and discovery. You have learned to reverse engineer blurbs that satisfy algorithms, generate semantic keyword strategies that align with user intent, and automate the production of marketing assets. Marketing is no longer a distraction from your writing, it is a system you manage. With your book written, edited, and now optimized for the market, only one phase remains. We must look at how to sustain this career over the long term.
Chapter 10, Ethical Compliance and Copyright Strategy. Sections, Section 10.1, Navigating the Legal Status of AI-Generated Content, Section 10.2, Transparency Standards and Disclosure Best Practices, Section 10.3, Preventing Plagiarism and Unintentional IP Infringement, Section 10.4, Future-proofing your catalog against regulatory changes. We have spent the entirety of this book accelerating your workflow. We engineered prompts to draft faster, edited with algorithmic ruthlessness, and automated the creation of visual and marketing assets. You now possess a high-velocity production engine. However, speed without steerage is a recipe for collision. In the traditional publishing world, liability was assumed to be human. If a book infringed on copyright, the author was to blame. In the age of generative AI, the lines of liability, ownership, and ethics have blurred. You are no longer just a writer, you are a compliance officer managing a synthetic workforce. This chapter is not legal advice, but rather a risk management framework. To build a sustainable career as an AI-augmented author, you must operate within current regulatory boundaries while preparing for future shifts. We will move beyond vague moralizing and focus on the practical mechanics of transparency, copyright eligibility, and catalog protection. 10.1 Navigating the legal status of AI-generated content. The legal landscape regarding generative AI is volatile, yet the core stance of major intellectual property offices, particularly the U.S. Copyright Office, USCO, has coalesced around a specific principle: human authorship. As of this writing, raw output from a machine cannot be copyrighted. This presents a strategic problem for the efficiency-minded author. If you generate a novel entirely via GPT-4 and publish it untouched, you likely own no copyright over that text. It enters the public domain immediately. The value of your intellectual property relies entirely on the human delta, the transformation you apply to the machine's output. To protect your rights, you must shift your mindset from generation to selection and arrangement. The law generally recognizes copyright in a work where the human has selected, arranged, and modified AI outputs to create a cohesive whole. Your workflow must generate evidence of this human involvement. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a copyright layer cake visualization. The bottom layer is labeled raw AI output in gray, public domain. The middle layer is human selection and arrangement in blue. The top layer is human editing and rewriting in gold. Arrows indicate that copyright protection only covers the blue and gold layers. The style should be isometric, clean vector technical art on a white background. The human delta workflow. You must ensure that your final manuscript is significantly different from the raw prompt returns. We achieve this through the iterative expansion method discussed in Chapter 5, but we now view it through a legal lens. Every edit, rephrase, and structural change adds a layer of copyrightable human expression. Do not rely on the work-for-hire mental model. The AI is not your employee. Legally, it is a tool similar to a camera. Just as a photographer does not own the light but owns the specific image captured through their creative choices, you own the specific textual arrangement you curated and refined. 10.2 Transparency Standards and Disclosure Best Practices. Publishing platforms are essentially data processors, and they require accurate metadata to function. Amazon KDP, Google Books, and others have instituted strict disclosure policies. Hiding the use of AI is not a clever hack, it is a violation of terms of service that can lead to permanent account bans. We must distinguish between AI-generated and AI-assisted. This distinction determines how you categorize your work during the upload process. AI-generated, the model created the content, text, images, or translations, with minimal human intervention. You prompted it, and it produced the final output. AI-assisted, you created the content yourself but used tools to brainstorm, edit, refine, or debug. The KDP Decision Matrix. When uploading your book, you will face a disclosure questionnaire. Honesty is the only efficiency strategy here, as detection algorithms are evolving. If you used the workflows in Chapter 5, drafting, or Chapter 8, visuals, you generally fall into the AI-generated category for those specific elements, even if you edited them. If you used the workflows in Chapter 7, editing, or Chapter 9, marketing, you typically fall under AI-assisted. The platform does not label your book as AI on the customer-facing store page, currently, but they track this data for quality control. Use the following JSON structure to maintain an internal disclosure log for every project. This ensures you can answer platform questions accurately years later. Project_ID, ISBN 978-0-12345-67. Disclosure_log. Text_status, AI assisted. Text_notes, used Claude 3 for developmental editing and brainstorming. Drafting was manual. Cover_art_status, AI generated. Cover_notes, Mid-Journey v6 base image, heavily composite in Photoshop. Interior_images, none. Translations, AI generated, DeepL, with human review. 10.3 Preventing plagiarism and unintentional IP infringement. A common misconception is that AI cannot plagiarize because it generates new tokens. This is technically false. If a model has overfit on specific training data, such as a famous poem or a unique block of code, it may reproduce it verbatim. As a publisher, strict liability often applies. Saying the AI did it is not a valid legal defense if your book contains copyrighted lyrics or plagiarized passages. You need a sanitation layer in your production pipeline. The temperature guardrail. In Chapter 2, we discussed temperature as a creativity lever. In this context, it is a safety lever. Low temperatures, 0.0 to 0.2, make the model deterministic and more likely to regurgitate training data. High temperatures, 0.7 to 1.0, force the model to predict less probable tokens, reducing the risk of verbatim copying. When generating non-fiction or technical explanations, avoid asking for famous examples without verifying them. Instead, use prompts that explicitly forbid direct quoting of existing sources. #Anti-plagiarism system prompt. You are a technical writing assistant. Do not quote existing copyrighted text verbatim. If explaining a standard concept, synthesize a new explanation using unique analogies. If a direct quote is necessary for context, flag it with citation needed so I can verify and attribute it manually. The reverse search protocol. Before finalizing any manuscript, run your content through a plagiarism checker. Tools like Grammarly or Turnitin are essential, but for AI-heavy workflows, you should also perform spot checks on unique metaphors or specific code snippets. For visual assets generated in Chapter 8, utilize reverse image search engines, like Google Lens or TinEye, on your generated characters. If your original protagonist looks exactly like a copyrighted character from a video game, you risk trademark infringement. Figure, extra detailed AI-ready prompt for AI-generated diagram of a sanitation pipeline. The visual flows left to right. Step 1, raw draft icon. Step 2, plagiarism scanner, magnifying glass over text. Step 3, fact verification, checklist. Step 4, human rewrite, pen icon. The background is a blueprint grid. Dark mode aesthetic with neon green indicators for safe and red for risk. 10.4 Future-proofing your catalog against regulatory changes. The laws governing AI are reactionary. They will change. A strategy that is compliant today may be non-compliant next year. To protect your backlist, you must future-proof your source files. The greatest risk to an AI-augmented author is the inability to prove human involvement. If a platform decides to purge low-effort AI content, you need an audit trail proving your work is high-effort and human-directed. Version control as legal defense. We utilize the version control concepts introduced in Chapter 6 for technical writing, but apply them here as a compliance strategy. Save your chats or prompt logs. Store the raw AI output separately from your final edited manuscript. This practice allows you to show the difference between the machine's suggestion and your published work. This difference is the tangible proof of your copyright claim. The hybrid asset strategy. Do not build a brand entirely dependent on one AI platform's aesthetics or availability. If you use Mid-Journey for illustrations, ensure you have the skills or the team to modify those assets in Photoshop. If you use GPT-4 for outlining, ensure you have the local copies of those outlines in standard formats, docx, MD. By maintaining the source files and the human-edited intermediate stages, you insulate yourself from platform shifts. You are not just storing text, you are archiving the evidence of your creative process.
Conclusion: building a sustainable AI workflow. Sections, Section 11.1, Constructing a Personal Prompt Library for Long-Term Reuse, Section 11.2, Balancing Automation with Authorial Intent, Section 11.3, Adapting to Rapid Advancements in Model Capabilities, Section 11.4, Final Roadmap for the AI-augmented author. We have journeyed through the architecture of modern authorship, moving from the foundational mechanics of prompt engineering to the rigorous demands of technical editing and compliance. You have built databases, automated critiques, and generated multimodal assets. The production engine we discussed in Chapter 10 is now assembled. However, a production engine is only valuable if it can run reliably over time without burning out the operator. Many early adopters of AI burn brightly and then crash, overwhelmed by the chaos of managing hundreds of disparate chat logs and disjointed text fragments. They treat AI as a slot machine, pulling the lever and hoping for a jackpot, rather than a precision tool. Sustainability requires structure. It requires shifting your mindset from generating text to managing a workflow. This final chapter is not about writing a single book, it is about establishing a repeatable, scalable system that will serve you for your next 10 books. We will codify your prompt engineering into a professional discipline. 11.1 Constructing a Personal Prompt Library for Long-Term Reuse. Amateur prompt engineers rewrite their instructions from scratch every time they open a chat window. This is the definition of inefficiency. In software development, programmers do not rewrite the code for its save button every time they build an app, they call upon a library of pre-tested code. You must treat your prompts as valuable intellectual property. If you spent 2 hours refining a prompt that perfectly captures your narrative voice, as perfected in Chapter 5, that prompt is an asset. It needs to be stored, versioned, and categorized. I recommend building a modular prompt library. Instead of storing massive, monolithic blocks of text, break your prompts down into reusable components, role, context, task, and constraints. This allows you to mix and match modules depending on the specific project. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a modular prompt library structure. Visual style, sleek, isometric technical schematic. The diagram displays a central database labeled prompt core. Connected to it are modules labeled tone, witty, format, markdown, task, summarize, and constraint, less than 500 words. Arrows show these combining into a final assembled prompt. Lighting is cool blue and white, emphasizing a clean, digital workspace. The most effective way to store these is not in a Word document, but in a structured data format like JSON or a dedicated note-taking tool that supports templating, such as Obsidian or Notion. Here is a conceptual example of how to structure a prompt entry for maximum reusability. Prompt_ID, char_voice_techno_thriller. Version 2.1. Last_tested_model, GPT-4. Modules. Role, you are a veteran cybersecurity analyst and fiction editor. Context, the scene takes place in a server room. High tension. Task, rewrite the user input to reflect terse, jargon-heavy dialogue. Constraints. No passive voice. Use sentence fragments for urgency. Maintain 8th grade readability score. Usage_notes, best used for climax scenes in technical thrillers. Fails if input text is too abstract. By standardizing your prompts, you remove the friction of blank page syndrome at the engineering level. You are no longer wondering how to talk to the AI, you are simply loading a configuration file. 11.2 Balancing automation with authorial intent. Efficiency does not mean total automation. There is a dangerous temptation, once you have a library of powerful prompts, to let the model generate chapter after chapter with minimal supervision. This is the fastest way to produce generic, soulless content that fails to connect with readers. We must return to the principle of authorial intent. You are the architect, the AI is the contractor. The architect does not lay every brick, but they must inspect the wall to ensure it follows the blueprints. If you abdicate your role as the visionary, the model will regress to the statistical mean, creating average, predictable prose. I utilize a workflow strategy called the intent sandwich. This ensures that human creativity wraps around every instance of AI generation, preserving the unique spark of your original idea. Top slice, human you write the detailed outline, the emotional beat, or the messy first draft. You define what happens and why it matters. The filling, AI the model expands, formats, or critiques the text based on your prompt library. It handles the heavy lifting of syntax and structure. Bottom slice, human you review the output, rewrite weak sentences, and inject specific nuances the AI missed. You verify facts, critical for the non-fiction discussed in Chapter 6, and finalize the tone. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the intent sandwich workflow. Visual style, cross-section visualization, distinct layers. Top layer is labeled human strategy, input, in warm gold tones. Middle layer is AI processing, expansion, in electric blue. Bottom layer is human refinement, polish, in warm gold. Connecting arrows show a cyclical feedback loop. Background is a dark, minimal grid. Use the following decision matrix to determine when to automate and when to write manually. Task category recommended approach reason. 11.3 Adapting to rapid advancements in model capabilities. The landscape of AI is volatile. A prompt that works perfectly today may break tomorrow when a model is updated. Alternatively, a new model might emerge that renders your complex prompt chains obsolete because it can handle the task in a single shot. To build a sustainable workflow, you must practice model agnosticism. Do not marry a single platform. If your workflow is entirely dependent on the specific quirks of one version of one model, you are building on a fault line. Focus your prompt engineering on fundamental logic rather than jailbreaks or trickery. Clear instructions, robust context, and precise constraints work across almost all large language models, LLMs. When a new model is released, you should be able to migrate your prompt library with minimal friction. I recommend establishing a golden set for regression testing. This is a small collection of standard tasks, for example, summarize this chapter or describe a character in a sci-fi setting that you run through every new model. Compare the output side by side. Does the new model follow instructions better? Is it more verbose? Does it hallucinate more? This objective testing allows you to switch tools confidently without disrupting your writing schedule. 11 Point for final roadmap for the AI-augmented author. We have reached the end of our technical manual, but this is the beginning of your production cycle. You now possess a toolkit that separates you from the hobbyist. You are not just writing, you are operating a content generation system. The roadmap for your future projects should look different now. It is no longer a linear path of write-edit-publish. It is a cyclic, iterative process powered by the assets you have built. Phase 1, pre-production, the setup. Before writing a single word of prose, you will configure your environment. You will update your prompt library. You will generate your style guides and character sheets, Chapter 4. You will define your target audience parameters for the marketing engine, Chapter 9. Phase 2, production, the sprint, you will write using the intent sandwich. You will use AI to overcome writer's block instantly, maintaining high velocity. You will generate visual assets in parallel with the text, Chapter 8, ensuring a cohesive aesthetic. Phase 3, post-production, the polish, you will deploy your automated editor, Chapter 7, to ruthlessly clean the manuscript. You will run your compliance checks, Chapter 10. You will transform your text into metadata, blurbs, and social content. The definition of an author is evolving. It is becoming less about the manual labor of typing and more about the executive management of ideas. Your value lies in your taste, your judgment, and your ability to direct these powerful systems toward a singular creative vision. You have the engineering knowledge. You have the prompts. You have the workflow. Now, go build the book. Thank you so much for taking the time to watch this overview. all about prompt engineering for book authors. I truly hope you found these strategies practical. More importantly, I hope you now feel a bit more inspired to actually use these tools to enhance your own creative process. By really mastering the art of the prompt, you are basically opening up a whole new world of possibilities for your writing. Now, if you did find value in this video today, please consider showing your support. Going down and hitting that like button? It really does help the channel grow quite a bit, and sharing this link with your fellow writer friends, that could be the exact boost they need for their next big project. Also, please don't forget to jump into the comment section below. I would genuinely love to hear your biggest takeaway from this session, or just tell me what kind of book you plan to write next using AI assistants. Thanks again for being here. Until next time, keep writing and stay creative.